Okay, this is the third and last part of the video series on advanced trinomial factoring. Of course, there will still be more factoring after this. Factoring is a very important skill, so we have lots of videos on it. But we're going to be doing the same thing here, but now we bring in the negative numbers. So this is actually the same problem that we started with in part 1, except now there's a negative 5 in front of the x instead of a positive 5. But we actually approach this problem the same way. We say, what are the factors of 2? They're going to be 1 and 2. We draw the x. What are the factors of 3? They're going to be 1 and 3. Now we multiply across. 1 times 3 is 3. 1 times 2 is 2. And 3 plus 2 is 5. But the problem is it's a positive 5, not a negative 5. So how do we get to a negative 5? Well, watch this. It's actually pretty simple. Instead of having 1 and 3 here, we do negative 1 and negative 3. Now, when we multiply across, it'll be 1 times negative 3 is negative 3. 2 times negative 1 is negative 2. And negative 3 plus negative 2 is negative 5. And the reason it still works with the positive 3 over here is because negative 1 and negative 3 are actually factors of 3, because the negative times the negative goes back to a positive. Negative 1 times negative 3 is 3. So it'll be x minus 1, 2x minus 3. All right, let's do another one like that. Factors of 3 are going to be 1 and 3. Factors of 7 are 1 and 7, but because we have negative here, instead of 1 and 7, we're going to use negative 1 and negative 7. Now, it's still important to put them in the right place. In order to get up to 22, we're going to have the 7 across from this 3. So negative 7 times negative 3 times negative 7 times 3 is negative 21. Negative 1 times 1 is negative 1. Negative 21 plus negative 1 is negative 22. And once again, negative 7 times negative 1 will go back to positive 7. So this will be x minus 7 and 3x minus 1. All right, so that's one type of factoring problem with negative numbers. Now, what if we have a problem with a negative coefficient of x and a negative constant on the outside like that? Well, let's see. We start with here. Factors of 2 are 1 and 2. But now we need two numbers that multiply to negative 3. So think about this. If they're multiplying to a negative number, then that means one has to be positive and one has to be negative. So factors of 3 would be 1 and 3. So that means we can either have positive 1, negative 3, or negative 1, positive 3. Now, here's where you have to start thinking ahead a little bit. Where we multiply across and then add those two results, it has to end up with negative 1. So, think about this. If we have 1 times 3, that'll be 3. And if we have 2 times 1, that'll be 2. 2 and 3 are 1 apart. That's good, because we need them to be 1 apart, so that when we add them, we'll get to negative 1. In order to make sure it's a negative 1, we need the 3. Multiplying across, we need the 3 to be negative and the 2 to be positive. So that means we're going to put a negative 3 here and a positive 1 here. So when we multiply across, 1 times -3 is -3, and 2 times 1 is +2. The -3 is one less, is one away from the +2. Well, the 3 is one away from 2, and that's the one that's negative, meaning that when we add, we'll get to -1. I know that might have been a little bit confusing, but that is how you have to think about these if you're going to do them in one step like that, which is going to be hard at first, but the more practice you do, the faster you'll do at getting them, because the reason I'm showing you this way is because when you have negative numbers now, there are even more possibilities to try, and it will take forever if you don't try to do some of this thinking in your head before you start solving the problems. All right, don't worry, we got lots more examples. Okay, so the factors of 3 had to be 1 and 3, of course. Now we need two numbers that will multiply to -8. So we have either 8 and 1 or 4 and 2, and one of them has to be positive, one of them has to be negative. So the first thing you want to think about is whether it's going to be 8 and 1 or 4 and 2. That'll narrow it down a bit. If you think about 8 and 1, putting the 8 here would be 24, which is way too much. If you put the 8 here, then the 1's there. That'll be 8 times 1 is 8. 3 times 1 is 11. That's not 10. So we know that 8 and 1 are out. That's good. Now we're down to 4 and 2. But we don't know which one's positive and which one's negative, and we don't know where they're going to go. So think about this. 3, if we put the 4 here, 3 times 4 will be 12. And that will leave us with a 2 over here. And 1 times 2 is 2. 12 and 2, those numbers that we'll get when we multiply across, are 10 apart. So that means that we have the correct numbers. The 4 is going to go here, and the 2 is going to go here. And in order to make it add up to -10, we have to make the 12 negative and the 2 positive. Put a negative here. That's -12. This is 2. We add them, and we get to -10. There's the correct factorization. I told you this was going to get hard, and yes, this is definitely one of the trickier things in factoring, and probably all of algebra. Okay. Factors of 1 and 3. Factors of 3 are 1 and 3. Okay, now this one we have positive coefficient in front of x, negative constant. So same thing over here on the right side of the x, we need one positive, one negative number. But now overall, when we multiply across and then add the results, we need a positive number. But this one's not quite so bad because the only factors of 2 are 1 and 2. We just know that 1 needs to be positive, 1's negative. So start thinking already about when we multiply across and add them, having them be 1 apart, because there's 1x here. So how can we do this? If we put a 2 here, 3 times 2 will be 6, 1 times 1 will be 1, and 6 and 1 are 5 apart, so that's no good. So putting a 2 here is not going to work, so we're going to put the 2 here. And that'll mean the 1 will go up here. So 3 times 1 is 3, 1 times 2 is 2, so that's good. Now they're 1 apart. We just need to figure out which one's negative. This is 3, that's 2. If we want positive 1, then we need to make the 2 negative, negative 2 plus positive 3 is positive 1. There we go. This is correct. All right, we're going to do another one just like that one. Factors of 5 are 1 and 5. Factors of 16 could be 1 and 16, 2 and 8, 4 and 4. Okay. If you think about this, 16 is just most likely not going to work. It's just way too high. If you put it times 5, that's crazy. We'll get up to 80. Even if we put it here, it's still 16. Whether that's going to be positive or a negative 16, it's still just way too high. So that's out. Let's think about 2 and 8. Putting an 8 across from the 5, that's going to be 40. That's probably too high. But what if we put the 8 across from the 1? That would leave a 2 here. But one of these has to be negative so that they multiply to negative 16. First, let's just check if this is right. 1 times 8 is 8. 5 times 2 is 10. And 10 and 8 are 2 apart. So these are the correct numbers. But which one of these is negative? Well, if this is 10 and that's 8, in order to get positive 2, the 8's going to be negative. So we'll put a negative right here. 1 times negative 8 is negative 8, plus 10 is positive 2. There we go. Okay, now that we have covered all those different types of problems, as you can see, depending on where the negatives are, it can be very different on what you have to do with them. So now let's do some mixed review. I'm going to throw all the different types of problems together. Now with this one, you have a negative coefficient of x squared. That would make things really hard. So what you want to do with that is get rid of it by multiplying / dividing the entire equation by negative 1, which will change all the signs. So negative becomes positive, positive becomes negative, and negative becomes positive. You negate the whole thing. Now, we have 13 here, which is pretty low considering we have 6 and a 6 here to work with. So let's just assume to start that we're going to pick the lower factors. Instead of 1 and 6 and 1 and 6, we're going to use 2 and 3 for both. So 2 and 3 on that side. 2 and 3 on this side. But where are we going to put them? We want to get to 13. So if we were to put the 3 here, that would be 9. 3 times 3 is 9. And then a 2 here. 2 times 2 is 4. 9 plus 4 is 13. So that's going to work. But we have 4 plus 9 is 13, not negative 13. In order to get negative 13 and keep a positive 6 here, meaning these two have to multiply to positive 6, they can both be negative. Negative 3 times negative 2 is still positive 6, but now when we add, it's negative 9 plus negative 4 is negative 13. So the factor result is 2x minus 3 times 3x minus 2. All right, this one is going to be pretty crazy. We're going to have a 36 there. But at least there's only one possibility for the 7. 1 and 7. You're never going to have negatives in these numbers on the left side of the x, because if you ever have negative coefficient in front of x squared, I say just get rid of it like we did here. And it's always possible to do these problems only having the negatives on the right side, so that's what I would advise. Okay, now we have 7 and 1 here. That's a pretty big difference. Now, Yeah, this one's pretty tricky. Okay, we have to get to 4 when we multiply across and add them. So because the 7 is so high, we're probably going to have the lower of the two factors of 36. So how low do we go? Well, let's start by making it really low. The 1, that would put a 36 here. Now, 36 even times 1, as you can see, is going to be 36. Whether that's negative or positive, it's way off. So let's go to the next set, which would be 2 and 18. 1 times 18 is 18. 7 times 2 is 14. Good. Now they are 4 apart. 14 and 18 are 4 apart. So these are the correct numbers. We just have to figure out where the negatives go. We're only going to have one of these two on the right side are negative because we need positive times negative in order to get a negative. So we have 14 here and 18 here. In order to get positive 4, we want the 14 to be negative and the 18 to be positive because negative 14 plus 18 will be positive 4. So that means we're going to put the negative right there. Negative 14 plus 18 is 4. And there's your factorization. Okay, a few more here. With this one, it looks very difficult, but always remember there are often things you can do before you start. First, we have a negative in front of here. We want to get rid of that. But while we're doing that, look at 8, 52, and 28. They're all even, which means they are divisible by 2. But even more so than that, they are all multiples of 4. If you happen to notice that, even better, because now we can divide them all by 4. Actually, it's going to be negative 4, because we're going to be negating the whole thing at the same time. So, in order to get rid of the negative here and lower these numbers, we're going to divide the whole thing by negative 4. Negative 8 will change to positive 2. 52 will change to negative 13. And 28 divided by negative 4 is negative 7. All of a sudden, this problem looks a lot more manageable. Factors of 2 are 1 and 2. Factors of 7 are just 1 and 7. We're going to put the 7 across from the 1 or across from the 2. Well, we got to get all the way up to 13. So we're going to put it across from the 2. That'll make 14. 1 times 1 will make 1. Now we need one of these to be negative in order to multiply to a negative number here. So it will be the 7 or the 1. Well, this is 1. This is 14. In order to get to negative 13, we want the negative 14 to be negative. So we put a negative in front of the 7 there. That's negative 14. That's positive 1. That adds to negative 13. And we're done. All right, last problem. Once again, definitely don't want to attempt something like this until you lower these numbers and get rid of that negative. 15, 39, and 24 are all multiples of 3. So we're going to divide by negative 3. And look at that. Hallelujah. Since they were all negatives, now they're all positives then when we divide by a negative number. This problem is going to be easy. Factors of 5 are 1 and 5. Now, we just have a couple of different combinations for 8. But here's a little trick. 5 plus 8 is going to be 13. So we want to have both the 5 and the 8 being multiplied by a 1. So we want to have an 8 being multiplied by a 1 and a 5 being multiplied by a 1. That way 5 plus 8 is 13. 5 times 1 plus 8 times 1 is also 13. So we end on an easier problem for once. All right. Yes, that was very challenging. You really should do a lot of practice on these problems because this will come up again in future units. This is probably one of the hardest, if not the hardest videos up until now. And yeah, factoring is not easy, especially this method. But if you can get good at it, you will be doing it very quickly, and the practice will pay off.